So let's have a look at setting up firewalling and security using the pfSense firewall. Okay, so this is the setup that we're going to go with. This is the firewall we're setting up. So there's three main ports. The WAN port, the LAN port, and then opt. Okay, we're going to allocate EM0, EM1, and EM2 to those three ports. The default gateway is over here, so we'll be hopefully setting that up later. So the WAN port should automatically get its address and default gateway and name server settings automatically from DHCP here, but we'll go and set these up as static addresses. So you'll be allocated a number here. So we'll go for a 1 and a 2 here. So this address is 1.7 and this is a Linux machine, and then this will be 2.7 and we'll have our Windows machine here. Okay, so the default gateway for this machine is here and the default gateway for this machine is there. Normally we set up just a few addresses and then we're able to HTTP in to the gateway port on the private network to set it up. So the things we're going to look at is to set up pfSense and some hosts. We'll set up ICMP so that we can actually ping around just to make sure everything is working okay. Typically we'll ping from the firewall out, and then we'll ping from the hosts on to the rest of the network. I'm going to examine some of the traffic. So we've got to enable ICMP, so we'll have a look at the network traffic that's responsible for that. Then we'll do a trace route from devices onto the network. Then after that we'll enable HTTP and FTP from the private into the DMZ, and then from the public to the DMZ, no connections into the private network. And then we'll enable Nmap from the private to the DMZ and vice versa. Okay, so let's make a start on that. Okay, so you should find the firewalls are in here, and we'll just take 01, we'll power it on, and let's assume that we're group 1. So what I'll do is I'll select a couple of hosts here and just power them on to be ready while the firewall boots up. Okay, there's a Linux and there's Windows. Okay, so that's them all booting up. Okay, so we'll just log into Linux 1 just so that we're all ready when we need to configure it. So that's on the private network. Okay, and then this one is the one on the DMZ. Right, okay, so that's ready to go with the firewall. Okay, so the first thing we're going to do is to find there's no VLANs. Not setting up any VLANs just now. And then as for the WAN port EM0, then the LAN port EM1, and the opt, which is our DMZ EM2. There's no more, so we press return and everything looks fine there. So it's now setting up the firewall for us. So the first thing we need to look at is whether the WAN port has been given an IP address, and it has from DHCP 10.200.0.205. So everything's fine there. So then the first thing we do is we set for a LAN port. It actually has a default of this, so I'll just show you how to set that up. Okay, so press 2. And we're going to configure the LAN port. That's the only one we need to configure just now. We just need to make a network connection to it. Okay, it's got the same address, but that's how you would do it. 24-bit, and everything's fine there. and we'll not enable the DHCP server on it just now. Okay, and that's fine. So then it should tell us that that's the address there that we connect to now. So we'll just do a quick ping just to see if everything's okay. So we'll ping 10.200.0.205. Okay, we're fine then. Okay, so let's try 192.168.1.1 and everything's fine there. Okay, so we'll now go to our Linux host and we should be able to connect into it. Okay, so here we are. Just bring the terminal up and let's have a look at what the IP address is just now. Right, so we want ETH10 to be set. 192.168.1.7 and net mask of 255.255.250 and it's up. Now we're going to set up a new route. I'm going to add default gateway. And let's try and ping the gateway. Ah, good. So it's alive. There's one more little thing that we need to do is to set up the name server. Obviously if it was working on DHCP then everything would be set up okay. Okay, so we're going to go into the resolve.conf and then we're going to add in our name server. Well, for the network is this. Oops. So let's just exit from there and do a sudo, because obviously that file's protected, and just put in our name server, which is the thing that's going to give us our name resolution. So that's there. Oops. Okay, that's good. Right, so now the magic begins. Okay, it's a standard HTTP connection that we're making. And that's a good sign that we have connectivity. That's because our name server was set there. So let's go and configure our firewall. Lovely. Okay, so now it's just admin pfSense and we'll log in. Okay, so first thing we'll do is we'll just enable this other interface and we'll give it an address. One 192.168.2.1 24 bits. Okay, so remember save and then remember apply here. Okay, so pretty much we've got our interfaces defined. There we are there. So there's our WAN. Okay, there is our LAN. And there is our opt1, which is the DMZ. Okay, so we can look at our ARP table. And the device that we're on, the Linux one, is here. Okay, so we can use ping. And this will define, so if we ping the connected node, 0.7, and we can take it from the LAN, say, we can do a ping. This allows us to ping from certain ports that we're actually on. Okay, so we can see there's a problem there, and the problem is that I've put in the wrong address. Let's try again. Okay, so everything's fine. Okay, so we've got the one network and we've got a two network. So go ahead and then we'll connect to the Windows machine. It's kind of easier to do the Windows machine. Okay, properties. There we go. There. Right. Okay, 192.168.2.7 default gateway. It's on the firewall 2.1, and our DNS comes from here. Okay, just takes a little minute to set. Okay, ping our own port 1.2.7. Ping the gateway. Okay, so it looks a bit strange, but it looks like we can't actually connect to the gateway even though it's connected. And what it is that we need to set ICMP as being allowed actually on that port. Okay, so for opt, what we'll do is I'll enable ICMP to pass. We can define where it's coming from, where the destination is, but we'll just make it any. We'll just apply that. And we'll do the same for the LAN. Okay, so let's do that. So pass interface LAN ICMP from any to any. That's fine. Okay, so we've got ICMP from any source to any destination on both of them now. There you go. Isn't that lovely? Okay, so by default, we were allowed to ping from the private, but not from the DMZ. So we needed to enable ICMP. So just to make sure that our main port out is accessible, so what we'll do is we'll enable a ping residing from that's coming into the WAN to do an ICMP on that one. That's good. Okay. Right, so now is the tricky time. So let's see if we can ping from a Linux machine to see if the routing is working. From the Linux machine 10.192. Okay, ping ourselves, ping the gateway, ping the other gateway, lovely, and ping the other Windows machine. Ah, perfect. Isn't that fantastic? Such a great little firewall. Just works out the box. Okay, ping ourselves. Ping the gateway. Ping the private network. Ping the host. Perfect. Okay, so it really shows how good a little device it actually is. So can we ping the main gateway? And we can. Okay, so that's why we get connectivity. But what we'll find is that if we try to access the internet from here, it won't work. And the reason it won't work is that we're firewalled. Okay, it's not allowing any connections to go through at all. But on the other machine, we could see the HTTP worked because that was enabled by default to allow us connectivity. Okay, all other services are currently locked down apart from ping. Okay, so let's do a quick trace route. And that should show us the ports that we go through to get to the gateway. So the trace route will work okay. DNS won't, because we've not enabled port 53 to be enabled through the firewall. Okay, so we'll just leave that to run. We'll go back to our firewall. Okay, it tells us that we've logged in. That's fine. So let's have a look at our firewall again. So there's a great diagnostics actually in it. We can actually capture from a certain interface. So let's say we want to capture from the DMZ that traffic, and we'll just make a start. Okay, let it capture some traffic first. Well, it didn't actually capture anything because I don't think we were really doing anything. So let's go ahead and do some ping from the private network. Okay, we're going to capture from LAN. Make a start. Okay, it's particularly useful when we're debugging. Okay. And there we go. Isn't that great? Isn't that fantastic? And you can download your capture to actually analyze it. Okay, so it's a great little method to them that we use. Another key area is really the routes that are set up. and it's important that you understand routing tables. Just takes a little minute to get that. Okay, so really this is our IPv4 here. So our default route goes to the gateway. Okay, that's been set up because the DHCP from the gateway on the WAN set up that as a default gateway for the whole device. We don't have to set it up. Now what we see is that anything for that network, 10.200, gets sent to EM0, of course. Okay, it's got a direct link to there. And then here, anything for the 1 network gets sent to EM1, and anything for the 2 network gets sent to EM2. Okay, so in that way we can actually look at our routing table and find out what connections that we should have. Okay, so let's stop pinging them. Okay, so we're starting to get there. So now what we'll do is just to show that nothing is getting through the firewall. Normally what we would do is nmap 192.168.2.7. So this is us nmapping into the DMZ. Okay, so you can see there's a whole lot of ports open. So if we now go to the Windows machine, and now we're going to nmap into the private network. Okay, so the Linux machine here is running a whole lot of services, but we shouldn't be able to see them because of the firewall. So the firewall will generally block most of the ports. Only ICMP is going to get allowed to be through. Okay, that was the result of our trace route here. You can see it just went straight to that address. It's routed through the firewall. Okay, so it's taking a bit longer because it's obviously blocking the ports. So there we go. So nothing is getting through. So everything gets through from private to public, but nothing gets through the other way around. Okay, so let's now enable. The DMZ to be able to connect into the private network. Okay, so there's our rules. Let's examine our rules just to see if we can understand what they're actually saying. Okay, so let's look at our rules. Okay, so only ICMP is allowed in, nothing else will be allowed in at all. For our LAN, so for LAN, okay, so ICMP is allowed. And for IPv4 is also allowed. So this is the rule that allows everything to go out. So we could get rid of that and we could do deny. We'll do a deny in a little minute. And so here we go, only ICMP is allowed out of our DMZ. Okay, so let's allow port 20. Okay, so the destination is anything, and destination port range, so we'll allow HTTP access. So we could log if we wanted and save that. Okay, so we'll just apply the changes. Okay, so now we should hopefully, now we should be able to pull up a browser here and access the host on the other network. Perfect. And now when we do an nmap, now HTTP should appear as a port. So we can do the same for other ports, but now what should happen is that, oh, there we go. Okay, so we've just opened up the firewall between the DMZ and the private network, in fact all networks, to allow HTTP out there. Okay, so let's see if we can actually lock down the ports. Okay, so what we'll do, so that allows anything like the LAN, so we've got to watch not to lock ourselves out. Okay, so we'll allow port 80 access so that we don't lock ourselves out. From accessing the firewall. We should be able to access it from the other place anyway, so it's okay. Right, okay, so we've got port 80, so that's fine, so we can get rid of this one. And then we'll just delete that row. And apply the changes. Hopefully we're still connected. Good. Okay, so let's see where we are. So we're only allowing out port 80 on our private network. So let's just try to see if that's the case. So 1.7 on port 80. Okay, that's good. Okay, we're getting connectivity. .7. Okay, so that's excellent. Okay, so that's certainly working. Okay, when we do an nmap now, as from before, we got all the services. Now they should be locked down. Okay, it's taking a bit longer. There we go. Okay, as if by magic. So HTTP service is open. Just watch that you don't lock yourself out of the firewall, because it'll be difficult to get back in again. So I opened up that there. So the NS lookup should actually be working. If I do an NS lookup on that, oops. Okay, and we see we've got some problems here. What we've got to do is to open up port 53 UDP. Okay, look, so it's timing out there, so we're not getting connection to our servers for a DNS lookup. So what we need to do is that it worked before, so if I now try Google, so Google's not working, but Google worked before, and the reason was that we've got rid of port 53. So let's now go and add a new rule, and we'll add for port 53. If you want, we could log that, log all the DNS, just in case. Okay, so I've now got port 53, and if we're using Google, actually we've got to put in HTTPS, because that's by default is HTTPS. So let's do that. Let's remember where we are, and we're on LAN, so our destination port is HTTPS. Apply that. Okay, so we've got 53 working, 443 and 80, and then, as if by magic, not yet. And the reason not yet is I've made a mistake here. That should have been UDP. So, a silly mistake. Okay, so I'll just delete that and redo it, because DNS is a UDP protocol. So let's do it again. Okay, UDP and TCP on port 53. Let's log. Okay, let's check again. So we've got HTTP, HTTPS, port 53 for all destinations, so everything should be fine. So fingers crossed. There. There we go. Okay, so the DNS is now working. Isn't that fantastic? Okay, so what we'll do is we'll make sure from the DMZ that we do the exact same thing. So we'll go to rules, and we want to go to the DMZ. We could obviously rename these, give them a neater name rather than opt1, but we'll just do that just now. Okay, so we need to enable for 53. So I'll just show you that it won't work just now, and then we'll go back and get it to work. Okay, so if I try Google, okay, so it's not working, and it's lookup for Google, and it's because the port 53 is blocked. Okay, for the DMZ. Okay, so let's go here, and then there, blah blah blah, 53 DNS. Remember TCP and UDP. We're on opt1. We'll log it. Okay, so the only thing now is to add HTTPS. So our lookup should work now. TCP, HTTPS. That's them. Okay, remember to apply. So just let's check 53. That's fine. That's fine. We've got ICMP. Everything's great. Okay, so we go go back to our Windows machine, here, here. Isn't that fantastic? Isn't that absolutely fantastic? Okay, so that shows you the setup there to be able to get these things to work. Okay, so the system logs is quite a good diagnostic tool to be able to look at. So there are system logs on the device, but obviously if you were going to do this properly, you would have a syslog server set up there. Okay, so just basically give you some of the main sort of system warnings. Here's the firewalling, so we can actually see it, we can actually log. So this was us doing our debug here, so this is the last 50 entries. And there's the UDP, and it actually shows us the rule that was actually hit and what it was related to. Okay, so there's the port 53. Remember we said we wanted to log on port 53, so this was allowing that out. Port 138 here wasn't allowed through, so obviously it didn't allow that to actually happen. Okay, so that shows our logs, especially if we actually see things here that could be malicious. And then there's a whole lot of other things, such as the DHCP log that we get, and some other things. Okay, so there's our gateways. This is an interesting scanner for gateways. Okay, so now let's go and set up our interface. So we want to go and set up some rules to allow some access into the DMZ from the WAN. Okay, so we're not going to allow any access to the private network. So this is from there. We'll allow it to go in HTTP, and the destination is going to be for the opt1 subnet. We'll just log that. Okay, so anything coming in a WAN on TCP to UDP is allowed. Okay, so we'll save that. So we'll also enable our FTP port. Again, only into the DMZ. We could lock it down to one node if we wanted, but we'll just make it for the whole lot. And again, we'll log that, and we may as well put it in a description. Okay, so absolutely no access from the public network into the private one. Okay, save that. And that's fine. Okay, so we could give that a better name. That's our DMZ. Okay, so you can see it's been changed to DMZ there. Okay, so that's us fine, and if we wanted we could just ping around just to see how things were going. But from our diagnostics we can actually do a ping, and so let's go from our WAN port just to see if we can get connectivity. And the answer should be no. Good. Okay, so there's can't get through because we've not allowed it from the public. Okay, so even 1 and so on. So if we want to make our servers available to be pinged from outside, what we'll do is we'll enable a rule for that one. Okay, so we've got a rule to go into our DMZ, and we allow ICMP in. Okay, so that's fine.